Okay, here we go. So we've been talking all about quadratics, and we've talked about all the properties and details that we can take away from vertex form. It's time we actually tried to get one of these on the graph. So, quick review. Vertex form. Y equals a times the quantity x minus h squared plus k, where h and k represent the coordinates of our vertex. Keeping in mind that what happens inside those parentheses, what happens underneath the square, generally looks the opposite of what we think. So x minus h is going to be a positive value, x plus h is going to be a negative value. Which if our vertex is at h comma k, then that means our axis of symmetry will be at x equals h. So now we've clearly defined where the middle of this graph is going to be. That's the best starting point we could possibly come up with. Here's an example. So if we start with the equation y equals x minus 3 squared plus 2. First thing we want to do is we want to be able to identify the fact that our vertex is going to be at 3, 2. Because if we think about this from a transformations perspective, we've moved 3 units to the right, we've moved 2 units up from 0, 0, where our parent curve was. And that means that our axis of symmetry is now at x equals 3. So let's transfer this to a graph. The details we need are the things that we'll plot first. We'll get our vertex in place, we'll identify our axis of symmetry. We're going to use the symmetry to not have to do as much to get this on a graph. So if we know that's where the middle is, then the next thing we need to do is build ourselves a table where that is the middle of our table. 3, 2. When x is 3, y is 2. We build around that. Most logical ones we use. 1, 2, 4, and 5, right in and around 3. So we start by evaluating one at a time. When I plug in 2, turns out I get 3. Plug in 1, I end up at 6. Now, this is where we use the symmetry. Because this graph is the same both on the left half and the right half, that means that that value I just got for 1 is also the value that I get for 5, because 1 and 5 are the same distance away from 3. The value I got for 2 is that same value I'm going to get for 4, because 2 and 4 are the same distance away from 3. Remember, 3 was the middle of this graph. I'll plot those points. Now I draw a smooth curve passing through all of them to create that parabola. Last details we need to talk about are we need to identify what the domain and the range are. Now, domain is still a free space. Our domain is negative infinity to infinity. Our range is all dependent on where this graph appears vertically. So if the lowest point is that vertex, and that value of 2 is what's identifying that low point, then I will work from 2 up to infinity.